Okay, guys, I'm going to read this to you. It's converting fractions from fractions to decimals. And I'm going to read the notes to you. It's basically the same concept of long division. So it's still kind of like dividing fractions. So I'm going to read this to you. It's going to say when converting fractions to decimal, you will usually have two integers in your fraction. So reason why I said integers because it could be positive or negative. And it's in a rational form, right? So like 2/4 rational form fraction. And you're going to perform a division on them, but instead of leaving a remainder, we're going to add at least 3 to 4 zeros, as I mentioned in dividing fractions, and continue a long division process. And again, the 3 to 4 zeros is a ECC standard. And, I'll take 3. I'm okay with 3 depending on if they ask you to round, as I explained in the last video. So, etc., etc. But here is what I want you to pay attention to. This is how decimals behave, especially if you convert fractions to decimal. These are the behaviors to expect. So sometimes the decimal will repeat themselves. It's called a recurring decimal. And it's represented with a bar over it, as you can see, right? So if I ask you to convert 1/3 into a decimal, 1/3 is actually 0.3333, etc., infinity. Or so instead of just, infinitely writing threes and you recognize that as being repeated, then you just put a bar at the top of it to show that it's a recurring decimal, right? Another example is that we can have one digit that recurs, or we can have two digits. So we have like a fraction 3/11, and here we go, it's 0.272727. So we see that two digits, the digits 2 and 7, are being repeated, so we put a line over that. So sometimes the decimal terminate, and you will not need to use those zeros that I mentioned. So for example, this is an improper fraction, and an improper fraction will always give you a whole number and a decimal. Anytime you have an improper fraction, it's hint, hint. You're going to have a whole number and a decimal. Okay, so when you convert it to a mix, because improper fractions can be converted into mix, and mix is a combination of a whole number and a proper fraction. So in this case, this is really 5/2 is really two halves if we were to convert them into a mixed number, which is actually 2.5. So that terminates at 2.5. All right, and then sometimes your decimals will go on to infinity. So stop at the last zeros, as I suggested, 3 to 4 zeros. And I'm not sure if this, I just pulled this example off the cusp, but I'm not sure if there's anything that repeats here. But when you do the calculation, this is as far as the calculator took me. So like I said, you will have your decimals that will either terminate, it will either reoccur, terminate, or go on to infinity. All right, so now let's do a couple examples. So for example, you could be asked to convert 2/7, 2/7 to a decimal. So you treat it like a long division. 7 is my divisor, 2 is my dividend, and it's clearly that there's no factors, those factors of 7 and 2. Now here's another hint. Once you have a proper fraction where the numerator is smaller than the denominator, or where your dividend is smaller than your divisor, you're going to have a decimal. So it's going to be a 0 point something, right? So here you just add the 3 to 4 zeros as I suggested, just to keep the integrity of what the institution want. I'm going to add 4 zeros, and then you start your long division. So there are no factors of 7 and 2, but I know I can find at least 2 factors of 7 and 20, which will give me 14, and I have a remainder of 6. Bring down a 0. I don't know my 7 times table. Oh my goodness. 7 times 8 is 56, right? 7 7 is 49, and 7 56. Yeah, 8. So that's 56. I subtract, and I bring down another 0. I have 7 times 5 is 35, right? And that's a 5. I bring down another 0. And I have 7 times 7 is 49. And as you can see, I can be adding zeros the whole time, but I'm going to stop at 4 zeros, at the 4th 0. And my answer, my conversion of 2/7 as a decimal is 0.287. 2,857. Or this is actually 2,857 ten thousandths, right? So let's do another one. Let's do 2/3. And I strategically choose 2/3 because you will see it's a recurring decimal. So 3 is my divisor. I'm going to add my standard 4 zeros. Then I'm going to start. So I know there are no factors. Again, it's a proper fraction. So hint, hint, zero there's no whole number there. So no factors of 3 and 2, but there are definitely 6 factors of 3 in 20, which gives me 18. And when I subtract, I have a remainder of 2. And then here you go. See what's happening there? 6, 18. And once you recognize that this is going to be reoccurring, you don't have to go any further. It's going to be 0.6 bar. Don't be tempted to do 0.66 bar. That's kind of redundant because it's 66666 all the time, okay? The 6 is the digit that's being repeated, not 66, all right? So here we go. That's how I represent my recurring decimal. So let's say I have an improper fraction. Let's say I have 7/3, right? Again, you can see clearly that this is an improper fraction. So if I was to convert this into a mixed number, I can find 2 factors of 3 and 7, and I'll have a remainder 1/3. So, hey, look at this bad boy. So this is like a little shortcut. Here it's 2 and 1/3. We already saw in our notes that 1/3 is 0.3 recurring, right? And then our whole number there is there, it's 2. So this is actually 2.3 bar, right? So that's one way of looking at this. If not, you can actually perform your division, add your 4 zeros, and here we can see we can actually find 2 factors of 3 and 7. So we have 3 times 2, 6, remainder 1. Bring down the 0, take up the point. And then we have 3 factors of 3 and 10. That gives us 9, remainder 1. We have 3, and then we see what's going to happen, right? So this is actually 2.3 bar. So you see there are ways you can perform converting your fractions into a decimal. All right. So that's nice, short and sweet. Have any questions? You know how to find me.